For centuries, every civilization measured the world in their own way. A king's arm span here, a grain of barley there, measurements based on whatever was at hand. The result? Nothing fitted together. Innovation ground to a halt. It was ever so slightly, well, chaotic. In 1901, Sir John Wolfe Barry, the engineer behind Tower Bridge, had a beautifully simple idea. What if we all agreed on how to make things? He started with the railways, 75 different rail sizes, none of them compatible. He got the industry in a room. 75 became 5. Costs fell, production sped up, British steel became competitive again. And BSI was born, the world's first national standards body. 2 years later, we created the kite mark. You've seen it thousands of times, that quiet symbol saying, you can trust this. By 1929, this rock-solid integrity earned Royal Charter status, recognition that standards weren't just about industry, but about delivering impact for a fair society and a sustainable world. 125 years on, and the kite mark is still keeping people safe. 2 world wars changed everything. We went from standardizing steel to saving lives. Air raid shelters, rationing. Then peacetime safety, seatbelts, motorcycle helmets, the 3-pin plug in your wall. We saw how standards could transform entire organizations. Before BS 5750, quality meant inspecting things at the end and hoping for the best. BSI changed that, giving businesses a framework to build quality into everything they do. ISO adopted it in 1987. Today, ISO 9000 is used by over 1 million organizations in 170 countries. One standard, one language, everywhere. Then came Rio. The 1992 Earth Summit was a global wake-up call, and businesses needed a way to respond. So we applied the same thinking to the environment. ISO 14001 proved you could protect the planet and still thrive. As standards went global, so did we. From America to Hong Kong and everywhere in between, we support 195 countries worldwide. As the internet revolutionized life, we created the guardrails. That padlock when you shop online, ISO 27001 keeps your data secure. Today, serving over 80,000 clients, our impact is shown in your results. We're leading the world's first net zero standard, showing how to actually achieve climate promises. We have created the first AI governance standard, making artificial intelligence work for you, not against you. Standards for psychological health, preventing modern slavery, supporting you through the menopause. Because standards aren't just about things, they're about people. We certify life-saving medical devices, test electric car chargers, secure smart homes. From China's railways to European hospitals, working with our stakeholders around the world, we support everything exciting that's coming. Self-driving cars, quantum computers, medical breakthroughs, renewable energy, happens because of the invisible infrastructure of standards. They turn brilliant ideas into trusted reality. For 125 years, we've been the thread that has transformed chaos into confidence, making local ideas global solutions. Our purpose hasn't changed, creating a fairer society and a sustainable world. BSI, 125 years of excellence, building the future together.
Good morning, all. I'm Joy Tan, the Senior Standards Manager for Digital Technologies at BSI. I'm delighted to welcome you to today's webinar on the integration of functional safety and cybersecurity measures, specifically the assumptions that underpin this integration and the consequences that follow from them. This is a topic of growing importance as systems become more connected, more software-driven, and increasingly exposed to both intentional and unintentional sources of harm and oversight. Traditionally, functional safety and cybersecurity evolved as distinct disciplines. Functional safety being focused on preventing harms which arise from random failures or foreseeable misuse, while cybersecurity addresses risk associated with malicious, adaptive, and intelligent threats. Each discipline has its own methods, standards, and assumptions about how systems fail and how those risks should be managed. However, in modern systems, particularly cyber-physical or digitally connected systems, the boundaries are blurring. Security-related events can directly compromise safety functions, and likewise, safety functions or mechanisms themselves may introduce new security vulnerabilities. As a result, there is increasing pressure to integrate these disciplines in design, assurance, and governance. This integration is necessary and desirable, yet it also raises important questions. What are the assumptions we're making when we combine safety and security frameworks? Where do they align or conflict? What are the practical consequences for system design, risk assessment, and accountability? Today's webinar aims to create a shared understanding of these issues and how we might address them, whether through standards and processes or implicitly through system architecture and operational practice. We are joined today by speakers with deep expertise across these domains, and I encourage you to engage actively in the polls and Q&A sessions in considering how these ideas and discussion relate to your role in the organization. Before we kick off, I'd like to run through some housekeeping rules. Please note that this is a listen-only webinar. Attendees' microphones and cameras will be switched off. Please submit your questions along the way by using the question button on the top right of the screen. Your questions will be addressed after the presentations. For any technical issues, you can report them through the same question box. A link to the webinar recording will be provided upon completion of the feedback survey. And finally, to learn more about BSI's upcoming events, do scan the QR code. And with that, I'm pleased to hand over to John Wiggins, our panel chair of Functional Safety and Cybersecurity, who will begin by setting out the landscape for today's discussion. John, over to you.
Thank you, Joy. As Joy has already said, you will be hearing from a group of UK experts on the impact this white paper can have. But let me first introduce the white paper. Next slide. And again, do you operate any of these systems? Increasingly, this is all of us. However, as Joy has said, the standards surrounding functional safety and cybersecurity have developed separately. And where problems exist, sticking plaster solutions have become common. The new BSI guidance aims to address these issues and to try to fix some of the underlying questions and underlying principles that's behind functional safety and cybersecurity. Slide. As I said, fields are developed in isolation. In many cases, the standards and regulations are not currently keeping pace. There has been a tendency to focus on technical measures and high-level strategies over practical guidance. This has left engineers and managers confused as to what to do. The key is to make informed decisions. To understand those decisions, we must first understand the assumptions we are making and what these mean in the real world. Here is where we step in. Slide. The key thing to emphasize here is this is practical guidance. This is looking at what is happening and how to address issues as they arise. The focus is on assumptions and the key decision points, but the guide is aimed for all parts of the life cycle, all decision-making exercises, and is there to allow informed decisions. The guide is split into cards which look at different decisions, different assumptions, and different areas of business work and different areas of projects and operations. The idea is to try and look at the assumptions you are making now and provide practical guidance on what this means and how to avoid the pitfalls of poor assumptions. Next. Why does this matter? Well, technology is increasing in complexity at a high rate. Regulation, as I've said, is behind, but is catching up. The focus of standards is shifting towards management and decision making. Make sure your decisions are sound. Also, we are increasingly in a world where technology will be retrofitted. And how do we achieve that? Slide. Says who? Well, engineers and managers such as yourselves say who. These people are people with the same challenges you have and the same experience, and probably the same experiences. Change. Next slide. So our panelists today come from a wide variety of industries and a wide variety of backgrounds. And before I introduce our first speaker, Tony Dodd, just let me say there will be a series of polls during this presentation, 30 to 40 seconds for you guys to contribute and give your views on the questions asked. Please do contribute to these polls. Slide. And finally, if you are interested in these subjects and you are interested in the field of cybersecurity and functional safety, GL 65 and GL 65-1 are looking for experts. Please contact BSI if you are interested. And now, without further ado, let us move to Tony Dodd and our first panel. Are we ready? Okay.
And if you kindly just come off camera, I'll launch the first poll. Thank you.
Very interesting. Yeah, the operational risks clearly are the most significant area so far. Thank you, everybody. That's very interesting answers.
Good morning, good afternoon, everybody. I'm Tony Dodd. I am a systems architect and product cybersecurity lead for Servomex. So the paper that we've created is deliberately broad, deliberately written to be broadly applicable across industry. And my role now is to narrow the lens, taking us from why this paper matters, which John has talked about, to why it matters to us, showing how, as an industrial product manufacturer, we find it useful, not as a standard to comply with, but as a way of challenging assumptions that can be made routinely in design, safety, security, and supply chain decisions. Servomex design and manufacture devices that measure gas concentration, and we've been a world leader in gas analysis instrumentation for over 70 years now. Next slide, please. And our devices are a component within a much larger system. So using the Purdue model, the diagram on the right, just to provide context rather than infer any network organization, that's us down at level 0 to 1, sensing gas concentration in a physical process, maybe a furnace, a chamber, a flue, something like that. And we're feeding our data into a high-level system for process control, for asset optimization, to support quality control, efficiency, and of course, safety. And what we're providing is sensing combined with RTU-like I/O behavior, just to make out-of-the-box kind of configuration and situational awareness for our customers easier. And from a manufacturer's point of view, our challenge isn't so much understanding functional safety or cybersecurity in isolation. There have been standards and guidance for both of those for years. They're still challenging, but they're not the real thing today. The challenge is that our products don't live in isolation. Our products live long lives, like many of your products probably do. They live in environments that we don't fully control, inside systems that we didn't design, and they're being modified, updated, serviced, and integrated by others. And those systems are increasingly complex and subject to more frequent change, as John said. So for us, the assumptions in this paper resonate because they reflect where manufacturers actually get caught out, not at initial certification, but years later, at the boundaries between disciplines, organizations, and life cycle phases. And with cybersecurity now being integrated at the device level, I want to use two of the assumption cards in the paper to make that more concrete. Next slide, please. So once you see devices as part of a layered system rather than isolated products, the first assumption worth challenging is whether those devices always behave as we expect. And this is what assumption card A1 in the paper talks about. So it talks about, the assumption is that systems have no emergent properties. But we need to refute that. An emergent property is simply a behavior or a capability that appears at the system level, a behavior that doesn't exist in individual components alone. And when we build systems, we do that precisely to benefit from the emergent behavior of the overall system. But it's the unintended, the unanalyzed, the uncontrolled emergent properties that can make our systems unsafe or insecure. And the Tacoma Narrows Bridge is a classic example. No component failed in this system, but the system as a whole behaved in a way that no one intended and no one expected. None of the component suppliers intended that outcome, of course. It only appeared once everything was integrated and included in the context of the environment, and that's important. This is where the emergent behavior, in the broader sense, happened. So from a manufacturer's perspective, in the present day, it matters because safety analysis often assumes benign, predictable behavior, and security analysis often assumes correct, functional behavior. And emergent behavior lives in the gap between those assumptions. Next slide, please. Just remember one part here. So the paper's helpful because it reminds us that the unexpected behavior will occur. It's a system reality that has to be managed. Safety and security are system level properties. They're not attributes that you bolt on independently. And if steel and wind can create unexpected behavior in the example of Tacoma Narrows Bridge, what happens when physics and field devices, control systems, software networks, and life cycle changes all interact? So unexpected behaviour isn't new. We've started to highlight the additional complexity of modern industrial systems with complex physics, those field devices, control systems. So what we're saying really is that our interaction space is vastly larger than it was historically. And from that large pool of kind of coupled properties, you know, this nebulous mass that this diagram is trying to convey, all of these properties and things that we need to think about, there are yet more hidden properties and behaviours that are going to surface. So the question isn't whether unexpected and unintended emergent behaviour occurs, it's more where and when that behaviour is going to occur. And the key point for manufacturers, and this is uncomfortable, is that when we design devices, our devices live inside those bigger systems that we don't design or control. We get integrated, we get reconfigured, we get networked, upgraded, serviced, often years after deployment. And the failures often don't come from defects in our products, but they emerge from interactions after deployment. Next slide, please. Oh, sorry, no. So yeah, I still need this one. So the manufacturer's response. There are three practical shifts here. Firstly, you know, we need to think in a system context. You know, we need to think about the environment that we're in, the interactions that we experience, not just think about our components. We need to think, what could this device enable within the context of the larger system? And what effects could the larger system have on our function? Secondly, we need to expect misuse and abuse now, not just faults. Real systems don't fail because the hardware breaks. They fail because configurations drift, maintenance shortcuts happen. You know, integrations are unexpected or devices get repurposed. And thirdly, we need to reassess behavior throughout the life cycle. The system that our device enters on day one isn't the system that the device is going to live in on day 10,000 of its life. Updates, modifications, and integration change behavior is going to occur, and we need to anticipate that to an extent. A fourth point that isn't on the slide here, but I think is really important, is that we need to consider resilience in everything. You know, emergent behavior can't be eliminated. So resilience is how manufacturers live safely with emergent properties. For example, consider the intrinsic resilience of the components that you're building. You know, minimize the scale and complexity of those, isolate or reduce interference between parts of your product, ensure that losses or delays in system interactions can't create unsafe behavior. Consider the industrial plant reality with brownouts and noise and resets, recover cleanly, avoid unsafe output glitches. Minimize opportunities for reconfigurations, support, detect and refuse unsafe operational configurations, and detect and don't propagate implausible inputs. There are lots of ways in which you can consider resilience in everything. Next slide, please. Once we accept that unexpected behavior can emerge, even in well-designed systems, the next assumption to challenge is that the product that arrives with our customers, with industrial plants, is the product that we designed, tested and certified. Customers interacting products into their systems naturally assume that the device they receive is genuine, is correctly configured, and is going to behave exactly as assured by us, the vendor. But in reality, between component sourcing, manufacturing, programming, configuration, logistics, commissioning, there are so many opportunities for the integrity of devices to be altered, sometimes accidentally, but of course, these days, sometimes deliberately. And the consequence is not just a data security problem. A device whose integrity has been compromised could mismeasure, it could fail to trip, it could behave unpredictably and reduce situational awareness or undermine safety function. So for manufacturers, protecting cyber and safety integrity go hand in hand. It's part of delivering the behavior that customers believe they've purchased. And in practice, that means thinking about component and firmware provenance and change, securing the manufacturing process, programming environments and distribution channels, providing access controls that cater for different users at different phases of the product's life as it progresses through supply chain, and access control that don't persist inappropriately after it's left a particular phase. We need to think about secure configuration and update processes. Next slide, please. So, in summary for my section, if we simply summarize the two assumptions that I've looked at, in A1, systems don't always behave as intended, and in D1, products don't always arrive as intended. And if we boil down the actions, I think it drives three changes. First, challenge assumptions early. We explicitly ask, what are we assuming to be true here? What happens if that isn't true? And that applies to determinism, to boundaries, insiders, supply chain. Secondly, we need to think about joint ownership. Functional safety and cybersecurity can't be separate silos with a handoff at the end. They must be co-owned system behaviors from concept through to acceptance and operation. And thirdly, lifecycle thinking. Most vulnerabilities are introduced during change, servicing, configuration, and updates, not initial design. So this guide gives us a structured way to test our processes against those realities without rewriting our entire safety and security management systems. Thank you. Next, there will be a second poll. So this poll is on the areas that are the biggest cyber and safety risks relating to operation and processes in your organization. So if you could just take a moment and engage to give us your responses. Thank you. So this question is designed to surface where operational cyber and safety risk is most concentrated today, rather than what formal controls exist. So, and the options here span to people, processes, technology, external dependencies. Heavily weighted towards inventory, information and assets. Very little on supply chain, which is surprising me. Here we go. Evening out now. Interesting. Thank you everyone for your responses. Fantastic, thank you. And now I'd like to hand over to Karim. So Karim is a cybersecurity specialist and director at CST Consultancy.
Thank you, Tony. Thank you. Thank you very much. Before starting, I would like to thank you all, or thank all the participants for being with us today. So, and thank you for making time for this event. I would like also to thank BSI and all the organizers for such event. So I saw the video and I felt proud of being part of BSI. So if you have time and you have some expertise, so feel free to reach out to BSI and be a member of BSI and contribute to our to history, actually, because when we see those innovation and how BSI was handling all that through all those years, so you will be very proud of being a member of BSI. So without any further ado, let's jump into it. So I would like to speak about two aspects. So the first is about, the first assumption is failure is only due to malicious intent. So obviously this is false, as you can assume, because we can have different other reason for failure. So for example, we can have human and organization failure. For example, we can have errors. We call that usually an intended deviation from intended action. It's just nice words to say that it's a lack of skill or lack of attention. So then we can have other failure, or reason for failure is violations. So usually this is a deliberate action. So it could be taking shortcuts to go fast or to go quickly. We can have as well some failure due to processes which might not be adequate or adapted for that organization. We can have other sort of failure, so mechanical, structural failure, like fatigue of the tools, or the stress of the equipment, or if it is, for example, metals, so it could be cracked down into the metals. Can have overload or on the equipment, and therefore not able to bear all that load and create some failure. There are other type of failure, obviously, so like single point of failure. So this is where you have component, or where organizations are relying on one component, and this is a single point where if it is failing, so everything is breaking down or blocked. So complex failure as well can be related to the unknown of the unknown. So when we don't know about something, and therefore we cannot guess that we will have such failure or predict such failure. So obviously, there are many types of failures, so we are not going to list them all here. But the idea here is to try to get some indicators and signs. So if we look at the next slide, we can see some of those indicators. So actually, those indicators are, for example, poor verifications and practice, so or poor resilience against any introduced threat. So for example, if we are forgetting a door open and locked, for example, and after finishing a task and or work. So this is also true not only for a server room, but it is true also for a network port. So if we leave a network port open and we go for a lunch, or we get caught on a call, or we get distracted, so those kind of poor verification or failure can happen due to that. So we can have some limitation of controls out as well. So thinking that the control in place will address more than what was expected, or eventually when we think that such control can address wider risk, but it's actually limited, and this creates failure. We have also the management of practices or lack of training or awareness. Not only general training, but also training about the control which are in place to make people abide by. So for example, turning off the power of on the meter and go and perform some electrical maintenance on the plant without putting any signage on the meter creates some issue at the end of the day, because obviously if no one is aware that there is a maintenance going on and they want to turn on the power, and then some might be hurt. So a lot of reason, or a lot of signs actually, and so this is where we need to keep that in mind. So obviously security measures are day-to-day operations. So sharing loggings, for example, it's a day-to-day operation, but it should not be done. Tailgating as well. So we are putting gates and doors just to make sure that we have a reason for that. For example, to identify the number of people inside the building, if there is any fire alarm, so we can identify that through those mechanisms. So tailgating will not help to identify or avoid such risk. And obviously, some of the signs are laziness and busyness. Obviously, human beings are a little bit busy and they want to go fast and quick sometimes, and they take some shortcut. So what we do about them? So first, we need to unify language. So unifying language, as we saw it on the video of the BSI, so it is good to help everyone work together. So this could be as well related to threats, fault, and risk within the organization itself. So we can work on improved risk assessment and include consideration of failure modes with its variety as well. So we can have a proper program in place for training awareness. This does not need to be expensive, as lesson learned from previous mistakes should be used as part of the awareness session and awareness training. So also access or assess what system behavior could induce as ad hoc modification, this as well, and a way to overcome those unknown or unknown information and try to sort that out and get through. So let's have a look at the other assumption through the next slide. So for the next one, the assumption is about compliance makes me secure. Obviously, as you can imagine, this assumption is false as well. So, and it has quite simple reason. Just we need to remember that compliance with a standard means that the implementer, so myself or the organization, if I'm doing the implementation, we are accepting the framework or the methodology set by that standard and get or to reach security level. In addition, that means we agree with the residual risk that was implemented or implicitly chosen by the standard writers. Then we can think as well why this assumption is false. It's because when we look at, for example, nationally defined by basic hygiene standards, they have a specific scope with some specific limitation for security protection. So for example, if we look at some standard, they are for commodity threat, and they have a limited exposure, or they have a limited focus on those commodity threat. And therefore, following or buying, binding by those standard doesn't mean that you are covered 100% for all type of risks, and that doesn't make you secure 100%. So compliance means that the system meet a quoted standard, but standards that can be out of date as well, because we update them. Some standards don't have any cycle for any update, and therefore they may not be appropriate for the environment or for the evolution of the environment. So compliance to any standard help reduce the number of potential issues, but it's not totally a total assurance for 100% issue-free system. And that's why actually we have insurance, because they are there to complement and help us with those residual risk. So let's have a look at some of those indicators actually and signs. So we can highlight that through this assumption that policy and processes for risk management activities with defined boundary are either not present or do not reflect the current activities and structure of the organization involved. So when asset owner assume vendors and system integrator have their risk covered, so this is a sign as well that something needs to be done. And when vendors and system integrator deliver a product or services to a fixed standard, so which does not go through any revision, so this is as well a sign that something is not doing well or something is probably going wrong. So what do we need to do about them? So let's have a look at that other section and review that. So on the next part. So first of all, we need to review the scope of each standard in use within the organization and its expected outcomes. So if the standard is meant to protect against commodity threat, it is not meant to cover state-supported or sponsored cyber attack. Therefore, we need to adjust and we need to pick additional standard and to cover such kind of attack and address such kind of risk. Similarly, expect to tailor controls to suit your organization or system circumstances. You may need some overlapping to ensure better security. Similarly, you might need some maintenance to maintain and continually assess and manage the risk with your suppliers. And this should be covered with vendors and system integrator, not only the buyer or whoever is using the system. And obviously, you might want to review those standards in accordance with the latest publication. So if there is a revision for the standard, so you need to be aware that maybe something did change and you might need to adjust or request additional improvement for your system and its controls. So let's move to the next slide. I think it's my last slide where I'm thanking everyone, and as well we are going through a poll. So and if you have this one, actually this poll is going to speak about or get your feedback about configuration and integrity in your organization, and then I will introduce our next speaker. So let's go with the poll. So which area are the biggest cyber and safety risk related to configuration and integrity in your organization? We have different options. So access control, protecting information, protecting against malware, backup, network and communication security. So obviously, if you think of anything else, you can add it into the Q&A, and we will take that into consideration. I'm seeing we have a lot of people concerned about network and communication security. 53%, that's quite a big, 59 even. So few are concerned about backups. We have protection against malware and protecting information. Those they have 11%, each of them. And access control. I think the poll is finished. So thank you for providing your feedback, and thank you for sharing your information with us. So our next speaker is Dr. Jenny. So actually, Jenny is the Managing Director of Method Compliance and Assurance Limited. So she is leading functional safety and compliance services for defense industry client, and she is well recognized for her expertise within IEC 61508. So Jenny, Oh, by the way, if you want to work with Jenny, so don't forget their website is, let me get it right, because I was there, and they have really good material and they have really good training course as well. So it's methodfs.com. So over to you, Jenny.
Thank you very much, Karim. What a fantastic introduction. Well, good morning, everybody. As Karim's mentioned, my name is Jenny Luthwaite, and I'm a functional safety engineer, and I'm primarily involved in hazard and risk assessment and those early life cycle activities. So today, I'm going to share some thoughts on what I took away after I read the technical guide, and what it should mean for my hazard and risk assessment practices. So I'm going to talk through some of the assumptions that are in the guide, how I feel they relate to my work, which is in the hazard and risk assessment area. We are running a little bit behind time, so I'm going to try and catch up by just skimming over some things, maybe not spending as much detail on all of the slides I was going to. But if you want to click onto the next slide, please. Perfect. So just a quick look on this one. The core challenge I think that's highlighted by the technical guide is that functional safety and cybersecurity have been effectively siloed over the years. They've largely evolved in parallel with their own models, their own terminology, their own interpretations of the world, and different processes for identifying, assessing risk. And to date, there's been a lack of guidance, perhaps, on the relationship between functional safety and cybersecurity, which has created some blind spots. Hazards can get assumed to be a cyber problem. Threats are assumed to be a safety problem. Sometimes they fall into neither bucket. So from a functional safety engineer's perspective, this means our traditional hazard and risk assessment can be incomplete if we don't start to explicitly consider cyber-driven failure modes. Hazards and threats can be overlooked, appropriate mitigations might not be implemented, and as a result, perhaps we can see an increase in incident frequency. Next slide, please. So the guide, as you've seen, organizes sort of typical dangerous assumptions into 5 groups presented as practical cards. I'm just going to go through some of the groups and just pull out some of the things that I felt were important that I took away as key learning points. And of the 5 assumption groups, it was group A that felt to me the most fundamental really for hazard and risk assessment, because it sort of challenges how we conceptualize the system itself. And some of those key learning points relevant to hazard and risk assessments are on this slide. Card A1 warns about assuming that the system has no emergent properties. So they can arise from hidden behaviors, from black box components, or maybe an incomplete interface definition. And if we treat these black boxes as fully understood, we underestimate both the safety hazards and the cyber exploitable behaviors. So our hazard and risk assessments become more optimistic models rather than reflections of reality. Our hazard assessment activities need to ask deeper questions of the potential behavior of composite systems. So are we considering the multiple sequential causes that's generally deployed by adversaries, for example, to bring about a cyber incident? And card A3 challenges that assumption that the system is deterministic, that given a specific input, a system will always produce the same output and follow the same sequence of states. So complex digital technology, particularly when under attack or at the edges of design conditions, behaves in ways that don't fit simple failure modeling. And hazard and risk analysis activities, we need to start considering that. In reality, hazards and threats evolve over time, and we should try to anticipate those changes and those surprises that are going to appear throughout the life of the system. Card A4 warns about over-focusing on hardware. So if our risk assessment underrepresents software, procedures, human interfaces, we can miss systematic or cyber-induced failures that may be far more likely in some cases than random hardware faults. And card A8, I think, is quite important culturally, is that safety sign-off doesn't automatically mean that security has been adequately assessed. We need to start looking at whether we can get joint sign-off, shared criteria for hazard and risk assessment activities. Okay, next slide, please. So group B, maintenance and monitoring, is more about that sort of ongoing life cycle. So how changes, incidents, operations can affect the risk landscape. So card B addresses modifications. If we assume our use case is fixed, we can overlook the need to design a system for safe or secure modification. And we've probably all come across systems that are difficult to modify. So they encourage on bolt-on modifications to address sort of short-term issues. And then these changes can in turn become a backdoor for new hazards and vulnerabilities, such as allowing unauthorized or malicious users to access our systems. Card B3 tackles the misconception that all hazards and threats can be identified at the start of a project. So for cyber-related hazards, that's almost never true. Threats and vulnerabilities evolve. As functional safety engineers, we need to encourage a shift from a one-off analysis to continuous risk assessment, scheduled reassessment of hazards, threats, protection layers, explicit interactions between functional safety and cybersecurity. Card B4 challenges the assumption that attacks will always be obvious. So many security incidents can sometimes appear to be random faults. And if cybersecurity risks haven't been considered with analysis risk assessment for the system, by the time we're sure of what the cause is, the damage could already be done. And card B6 can remind us that what's secure enough today won't necessarily be secure enough tomorrow. So the cyber threat landscape is continually evolving. New vulnerabilities are discovered, new exploits are crafted, and there's new motivations realized on a daily, if not more frequent basis. Okay, next card, please. Group C focuses on interfaces, which are often where our assumptions are weakest. And card C1 challenges the idea that there's a perfect security boundary, when in reality our systems depend on external services, supply chains, trusted components outside of our direct control, and even trusted insiders, operators, contractors who interact with the digital system. So in hazard and risk assessment, we need to start explicitly modeling dependencies and relationships which are beyond our intermediate boundary and include them in our risk analysis. And in my experience, safety and security often operate independently of each other, with each sort of quietly assuming that the other one's got everything covered. However, with no one's really covering the joint risks, so security assumes perfect safety, safety assumes perfect security. So effective hazard assessment, therefore, is going to benefit from considering both safety and security by preferably a joint team. And as functional safety engineers, we need to start explicitly building security measures into our protection layers rather than treating them as somebody else's job. And the last point is commonly there's an assumption that safety measures have got no impact on security and vice versa. Now, in practice, a security response can trigger or mask unsafe behavior if it's not been designed alongside safety. So for me, this means treating safety and security measures at interacting layers and testing for those interactions in our assessments. So I think you can skip the next slide about groups D and E. We can pop straight to key learnings. That's it, perfect, thank you. So I'm going to pull this together with three big learnings realistically for how I think hazard and risk assessment maybe needs to start incorporating more of those aspects I've just spoken through. So first is that the hazard and risk assessment activities need to consider integration of the system, and as part of that consider emergent properties, undocumented capabilities, unexpected behaviors of interfaces. Second, we need to start treating functional safety and cybersecurity as two views of the same risk landscape. Risks to safety and risks to security can't not be identified and treated in isolation. Third, risk assessment's not a one-off activity. It needs to be revisited as the environment, the threat landscape, system configuration, and supply chain, for example, all evolve. So to close, from a functional safety engineer's point of view, the key message is that safety cannot be assured unless we are explicitly accounting for cybersecurity in our hazard and risk assessments. So this guide, in my opinion, it's not asking functional safety engineers to become cyber experts. It's asking them to stop treating cybersecurity as somebody else's problem. And it's emphasizing the need for functional safety engineers to treat cybersecurity as an integral part of safety, challenge hidden assumptions in projects, and build joint lifecycle-wide practices with security teams to keep systems as safe as we can while threats evolve. And if we adopt these assumptions as a checklist throughout the lifecycle, we can strengthen both our safety arguments and our cyber resilience. So I would encourage us to start treating these card groups in the technical guide as part of our standard prep for hazard and risk assessment activities. So thank you to everyone for listening. We're now going to have our final poll of the seminar. So I need to switch off my screen and we can wait for that to appear. Okay, here it is. So which areas are the biggest cyber and safety risks, relating to maintenance and monitoring in your organization? We have some options here for you to choose from. Let's see what people think. Okay, remote maintenance seems to be leading the way quite strongly. We're hovering around 60%. Okay. Thank you very much for your input, everybody. Yeah, there we are, 67% remote maintenance access, including third parties. Okay, thank you everybody for participating in that. I'm going to hand over to Peter and John now, who are going to try and fit in a very quick Q&A session for us.
Thank you, Jenny, and thank you to all the previous speakers. May I now introduce Peter Brown of Lloyd's Register, who is going to lead the Q&A session.
Thanks, John. Morning, everyone. Thank you for coming. My job here is to help the team out by coordinating the questions at the end. So I'll crack straight on. If the presenters and everyone could come back on camera, that'd be brilliant, please. The first one I'll ask is for Tony. You said that the questions can be used to test our current procedures, and this question is broken down into two parts. Do you have ideas about what those procedures should look like? And the second part is, do you see harmonized functional safety and cybersecurity procedures captured in any published standards? And I can repeat either or of those for you, Tony.
Sure, thank you. So yes, if I address the second question first, if I may. So there is a combined standard. John will probably help me out. I think it's 60369.
It's 3069.
3069.
Yeah.
Right.
Some of those on this call have worked in the committees in addressing comments on that particular combined standard that tries to address kind of the combined processes to resolve the tension between safety and cybersecurity sort of process development. So that exists. I believe there are also other publications that talk about that. So there's one from the IET. Peter, you would probably be best to comment on that. I think you know that IET document again. I can't remember the name off the top of my head.
Yeah, that's fine. That's fine. Yeah. So there are a few. There's a few bits of guidance, and maybe the other thing worth mentioning, Tony, maybe is the fact that consciously committees that are writing standards such as 61508 or 62443 from the other side, that they are consciously not putting too much requirements from the other discipline in their standard to avoid complexity of standards writing. So
Absolutely.
Although there are some that overlap, there are others that are deliberately trying not to overlap. So we have this sort of mixed message and slight complexity even in the standard side of them themselves.
Yeah, I think it's an interesting point, and we reflect on it a lot in the group discussions. The standards are complex enough, and that's why we've not produced another standard here to try and get some practical guidance instead. The standards are already big and complex, and they've got a lot in them. So trying to cover safety in a security standard, or vice versa, would just be too much. They need to remain separate because there's so much to them, but we need to have other guidance to help resolve. And in a manufacturing business, you know, we embed, essentially we have a standard product development life cycle, on top of which we build the additional layers for cybersecurity, you know, secure development life cycle and a safety development life cycle. And depending on the project and the product that we're building, we pull in through our quality plan for that project the additional activities and process steps required to consider those particular areas. So for us, it is a combined, you know, approach.
Okay, thank you. Okay, so I'll move on quickly then, because we haven't got too much time for too many questions. I'll go to Karim next. You indicated that compliance with existing standards is insufficient to make us safe and secure. Do you see a new standard that bridges existing standards being part of the solution? So that sort of follows on from the sort of discussion we just had.
Yes, indeed. So the thing is, depends on the organization scope and their activities. So, and we have different standards. So actually within the UK, we have different standards. So we start with the NCSE's standards. So like the Cyber Essential Plus. So for any organization, just to focus on their IT part. When it goes to the NCSE actually developed standards for and guidance for critical systems, and their focus is mainly on that. Similarly, they have the 10-step for cybersecurity. We have NCSE guidance for industrial control system. We have the NIST guidance for industrial control system. And recently, we know that, for example, the MOD is working on another standard, which is the Defense Cybersecurity scheme or standard. And so depends on the organization, what is their main focus. Are they working on defense? Are they working on medical equipment, or are they working for the good and supply? So they need to look at some of those standards to address those kind of issues.
Okay, thank you. And I guess that was one of the guiding principles behind this guidance was this confusion for the markets, depending on which market you're in, what standards you're using, etc. So thank you. And then for Jenny, do you think we can deliver the key learnings without both disciplines changing the way we are currently taught to work?
I think my key takeaway from the paper is that we're not trying to take over each other's specialisms. We actually just need to find ways of working together better. And I think anybody who is involved in safety has been through this, you know, in the past, with safety being considered something that you did right at the end just to check you've done everything right. And slowly and surely over the last, goodness, I don't know, decade, 15 years perhaps, it's become something that's understood, integrating it into the beginning of the life cycle. Also, it doesn't just make your design easier, but it's got cost benefits and you know, benefits throughout life. So I think if we can start to implement the same thing, that you don't just look at cyber at the end and you check you've ticked all the boxes and therefore you are cyber secure. We start to bring it in the part of the life cycle that I'm involved in, that hazard and risk assessment, which is the first things you start to do. If we can start integrating cyber, and we can get functional safety and we can get cyber people talking together at early stages and discussing the key points that are, you know, flow throughout this technical guide. I think that's where the key learning point for me is.
Yeah, good. Personally, that was probably one of the key requirements for me in starting down this road with this panel, was to try and get those people. So I talked to some people, and in some areas, some people say, oh, we work together well, but you also talk to other people where, you know, it's chaos, it's confusion, it's, you know, so you get every extreme from one to the other. Thank you. And I guess, sorry, we're over in a little bit. We'll have one final question, which I maybe point more at John, because he's been sat there quietly for a bit. So how does an organization integrate this type of document into their procedures and policies, especially related to things like making decisions and aspects like that?
So it's really down to, you know, the idea of sitting down and actually going through why you are doing what you are doing. So how to integrate it into your procedures. You can, I mean, you know, at the most simple level, a checklist. Have you considered these factors? But use it before then. Use it at the very beginning. So when you are contracting a project or starting an activity, take that and say, okay, these are some key metrics that we can build in to the performance indicators that we're going to use, and build it in at that level. And then you're going to start on the right path. At the end, it is a validation exercise to say, yes, we have achieved what we set out to do. And you use the antithesis part to check yourself. So, you know, start early and try to ingrain the behaviours and the thought processes that this document puts out.
Okay, thank you. So thank you very much to everyone from our side and the presenter side for joining us today and listening to us talk. I'll hand over now to Joy to wrap up. If there's any more questions, feel free to ask them. We'll endeavour to, you know, answer questions after the fact as well.
Thank you, Pete. As we conclude, I would like to thank all our speakers and all participants for this very constructive discussion. I hope that the arguments have encouraged much reflection that will be part of an ongoing conversation in fostering deeper collaboration and technical contributions to the world of standards. If you were inspired by today's session and would like to deepen your involvement, do consider joining as a standards maker by signing up as a committee member on BSI's webpage. Alternatively, there is also the BSI Young Professional Network, which is a welcoming community designed to support emerging professionals in building their expertise, expanding their networks, and playing an active role in shaping standards. Finally, do explore the complimentary copy of the white paper that's available in the handout section. And with that, I'll formally close the session, and I wish you all a very good afternoon ahead. Thank you.